Hello guys, today we will discuss the Abel test for uniform convergence of series of function. And the statement of this test is, if summation f and x is uniformly convergent series in a given interval, closed interval AB, the sequence g and x is monotonic decreasing for all x belongs to closed interval AB. There exists a positive number k such that mod of g and x is strictly less than k, where k is free from x, that is for all x value of closed interval AB, and n belongs to natural number. Then the series summation f and x g and x is uniformly convergent. That means the convergence of product of two sequences depends on its nature. The first series should be convergent and the second g and x sequence should be monotonically decreasing, and it should be decreasing. So its proof is, since summation f and x converges uniformly on closed interval AB, hence by Cauchy's general principle of uniform convergence, we know that for each given epsilon greater than 0 and for all x belongs to closed interval AB, there exists a positive integer small m, and this m does not depend on the value of small x, it's only depend on the value of epsilon, such that mod of fn plus 1x, fn plus 2x up to fn plus px should be less than epsilon upon k for all n greater than equal to m and p belongs to natural number. And this gives us summation sum of frx from Rn plus 1 to n plus p should be less than epsilon upon k for all values of n greater than m and p belongs to natural number. Now from the assumption first and second, we see that the sequence g and x is monotonically decreasing on closed interval AB, and also it is bounded by a positive integer small k for all x belongs to closed interval AB. Hence from the assumption second and third, we see that g and x is monotonic decreasing for all a and b, and this is bounded. Hence by Abelslemma we obtain the mod of summation frx grx, where r is from n plus 1 to n plus p, is strictly less than epsilon upon k into k, that means is equal to epsilon for all n greater than m and p belongs to natural number. Here is the Abelslemma. It says that if a sum of series from m to p is bounded between k and capital K, and sequence a n is monotonic positive decreasing sequence, then the product of summation ur and an, r is equal to m to n, is lies between amk into am capital K. So by using this lemma we obtain this inequality, and this inequality implies that the mod of fn plus 1x into gn plus 1x up to fn plus px into gnx n plus px is less than epsilon. That means the product of fnx and gnx is uniformly convergent series by Cauchy's general principle of uniform convergence. Now by using the Abel test, we will check the uniform convergency of given series. So here we have given series minus 1 to the power n minus 1 whole upon n into x to the power n, mod x to the power n, where x belongs to minus 1 to 1. Let fnx, we assume that fnx is equal to minus 1 to the whole power n minus 1 upon n, and we assume gnx is equal to mod x to the power n. Here the fnx series summation fnx is convergent by Leibniz test. Leibniz test says that if an alternative series is monotonically decreasing and decreasing to 0, then it is a convergent series. So here it is alternative series and 1 upon n tends to 0. So this series is convergent by Leibniz test. Since each fnx is independent of x, here x is not lies, so that means this series is independent from x. Therefore this series is uniformly convergent. So it satisfies our first assumption of Leibniz test. Now gnx, again for all x belongs to minus 1 to 1, mod x to the power n is always positive number and its value will be less than equal to 1 for all x lies between minus 1 to 1 and for all n belongs to natural number. And mod of gnx is bounded. That means the sequence gnx is a monotonic decreasing and bounded on closed interval minus 1 to 1 for all n belongs to natural number. Hence, by Abel test, the given series summation fnx gnx, which is summation minus 1 to the power n minus 1 upon n, is uniformly convergent on closed interval minus 1 to 1.